Hello grade 11s. Today we will join Bobby as he proves and applies the area rule. The area rule helps us solve non-right-angled triangles. In order to use the rule, we need to know the size of two of the sides of a triangle, as well as the size of the included angle. Let's cross to Bobby now as he shows us how to use the area rule to find the area of a piece of land between a river and two roads.
We are here at a fork in the road and both roads lead down to the river. But before we go on, why don't you make a sketch of the key details? I will help you identify them on the map. The distance from here to the river along this road is 1.5 kilometers. And it's 1.9 kilometers down this road. The road splits at an angle of 78 degrees. The area between the roads and the river is an area of natural bush. The area presents a fire hazard. The conservation officer has asked us to find out how big this area is because she needs to know how many firefighters are needed to cover the area.
If we want to find out how many firefighters are needed, then we need to work out the area that each firefighter can cover.
The conservation officer will do that. All she wants from us is the area of the piece of land. Now, any ideas on how we can go about finding it?
Didn't we learn the formula for area of a triangle in geometry?
Yes, we did. It was half times base times perpendicular height. But I don't understand what that has to do with trigonometry.
Well, let's take a look at this formula for area and see if we can use it. The area of a triangle is equal to half of the base multiplied by the perpendicular height. So we need to know the length of the base and the length of the perpendicular height.
If we take BC as the base, then we have no idea what the length of the river is, and that won't help us. And if we take AC as the base, then the perpendicular height should be somewhere here. But we don't know that either. I don't think this formula can help us.
Then can't we just measure the distances?
This is only a sketch. It's not according to scale, so measuring won't help us.
Actually, your formula for area has its uses. Mathematicians used it as a starting point to work out another formula for area using trigonometry. And this is the formula you're going to use today. Have a look at it.
Let's see. It says that the area of triangle ABC is half BC times sine A. In our triangle, angle A is here. But where are B and C? B is the side opposite angle B. So that's AC. C is the side opposite angle C. That's here. That's interesting. It looks like this formula doesn't need us to know any perpendicular height.
That is so useful. We're first going to use this formula and then later see how to derive this formula.
Now let's see what values we can put into the formula, and if we can calculate the answer by using the formula. Okay, the formula says that the area will be half times B, that's 1.9 kilometers, times C, that's 1.5 kilometers, times the sine of 78 degrees.
I'll start with sine of 78 degrees. Then times by 0.5 times 1.9 times 1.5 equals 1,39386.
The values were in kilometers, so our answers here must be in square kilometers.
Great stuff. By just substituting the values into the area formula, you found the area of natural bush in the triangle. In square units, the area of the bush is just under 1.5 square kilometers. As I said before, we can leave it to the conservationists to work out how many firefighters they're going to need. Now have another look at your sketch. How much information do you think you need before you can use this area formula?
Well, we use the lengths of the roads and the angle between the two roads.
Good. Now to use this formula, you need at least 3 pieces of information about the triangle. But here's another important thing to remember. The angle that you use needs to be the angle that is between the two known sides. We call this the included angle.
It's all very well giving us the formula of the triangle, but what if, let's say, we only knew angle B and not angle A?
Good question. The area rule says area equals half B times C times sine A. So what do you think the formula would be if you only knew angle B?
First, I guess we'd have to be sure that angle B was between two known sides. So we would need to know the lengths of side C here and side A, which is over here. Now what?
You're almost there. Have a look at the formula now. The angle you know is B here and the sides you know are A and C.
Now I get it. The formula will be the area of triangle ABC equals half AC sine B.
Can you see the pattern? If we have angle B, we need sides A and C. So if we know angle C, how will the formula change?
In the formula, we need sine of C. Angle C is here, in between side A and side B. So the formula will be half AB times sine C.
So we have three versions of the formula, but you don't need to learn all of them. You can work them out from the diagram. Okay guys, are we ready for our next challenge?
Absolutely.
I never say no to a challenge.
Okay then, let's go. Okay everyone, we're here.
Who put these poles here?
Who do you think? These poles make a triangle on the ground. The area inside the triangle is 28 square meters. This time you may need to do some measuring. Your challenge is to find the angle between the shortest pole and the longest pole.
Why?
This challenge is about practicing maths. Sometimes it's good practice to improve skills so that we can solve problems where maths is needed.
I'm okay with that. So I'm going to start by drawing a triangle and then labeling it. I'll make this point W, and this can be point X, and this can be point Y. The shortest side is WY and the longest side is XY.
So if we label our sides X, Y and W, then those two lines will become X and W. And we'll have to use our formula to get our angle in between, which will become angle Y.
So why don't we just measure both sides? I mean, I've got a tape measure.
X is 7 meters. And W is 10 meters.
Got it.
So, now that you have the diagram with some of the measurements, can you use the formula to work out the size of angle Y?
Okay, let's first see what the formula will be.
If X is 7 meters and W is 10 meters, then 28 equals half times 10 times 7 times sine of angle Y. So 28 equals 35 times sine Y.
If we divide both sides by 35, we'll get sine of Y equal to 28 divided by 35. That's quite hard, so I guess we'll have to use a calculator.
Right, so that's 28 divided by 35 is 0,8. So if sine Y is 0,8,
to get angle Y, we must use the inverse sine key on the calculator. That comes to 53,13 degrees. Let's round that off to 2 decimal places.
Well done. You've worked hard. Now there's one more thing that I have to show you, and that is how to derive the formula that we've been using to work out all these questions. To start with, let's take any triangle, PQR, and let's label its sides P, Q, and R. We'll try to prove that area of PQR is half of P times Q times sine R. First, we construct a perpendicular line from P to the opposite side. Let's label this point T. Do you see how this splits the triangle PQR into 2 right-angled triangles? Now, using the formula, the area of triangle PQR is half the base times the perpendicular height. So, what are the base and the perpendicular height of this triangle?
the base is RQ or P, and the perpendicular height is PT. So the area will be half P times PT. How does that help us?
Be patient. Let's see how the two right-angled triangles can help us. Look at triangle PRT. What is the sine of angle R?
It will be the length of the opposite side divided by the hypotenuse. That's PT divided by Q.
Yes, and I'm interested in getting PT by itself. If we multiply both sides of this equation by Q, we'll get PT equal to Q times the sine of angle R.
I see where you're going with this. Look, PT is in the area equation up here and in this equation. So we can put Q sine R into the area equation.
And if we substitute what we have for PT into the area equation, we find that the area is half P times Q times sine of angle R. And that's it.
That's what? You've lost me.
We've proven that when two sides and an included angle are known, we can use the area formula to calculate the area of a triangle. We can use this in any triangle. For example, here is triangle XYZ. If I know side X, side Y, and angle Z, the area rule says that the area of triangle XYZ is equal to half side X multiplied by side Y multiplied by the sine of angle Z. Now that we've shown that the rule is true, we can use it confidently whenever we know the lengths of two sides and an included angle.
That was a comprehensive explanation of the area rule. The questions that were done are all examples of typical examination questions in this section. Thank you, grade 11s, for joining us. Remember to look at the tasks for this section in sine, cosine, and area rules task video. You will be able to learn more about the area rule on our website, www.mindset.co.za/learn. Area rules, okay?